So the binomial theorem is going to be used to expand binomials to a certain power without having to actually multiply them all out and do FOIL and then FOIL again and then distribute and distribute and distribute and distribute, because some of these would be impressive to do out like that. So there's like a shortcut formula to that. And it involves something called Pascal's triangle. So what we're going to first do is take a look at what Pascal's triangle is and then how to use it. Okay, so you have this on your paper with the blanks. And yes, there are numbers. And yes, it's all filled out next to it, but I want you to see where it comes from, just in case you're trying to get a note card together and you don't have room for the whole Pascal's triangle. It's very easy to make a Pascal's triangle. Let me see if I can get you an eraser. And so, we have that. Okay, so where the numbers come from, and this is where I'm going to have you fill in just so that you're used to doing the process. It starts with 1 at the top, and it is making a triangle, so then there's 2 1s here, and then 1, 2, 1, and then look up for a second. The numbers that go down below are taken by adding these 2 together. So the number that goes in there is going to be a 3. And the number that goes in here is 2 plus 1, which makes 3. Because you're like adding down the way. So that means that down here is going to be 1 plus 3, 4. Okay? What number goes in here? 6. And what number goes in here? 4. Okay, then we do the next row. And you're filling in row after row. This number here is a 5. This one is a 10. Then 10 again. 5. And then you're again adding up. So this number is 6. Then in here we have 15, because 5 plus 10 here, 10 plus 10 gives you 20. This one is 15 again, and then this one is 6. Then the next row we get 7, 21, 35, 35, another 21, and 7. Okay, and it's a little bit faster to just do that than it is to just look at the one that's completed right next to it. This next one is 8, 28, 56, 70, and then it starts to repeat as it goes back down. Everybody see that it's kind of like a symmetric pattern here? Okay, so we have Pascal's triangle, and Pascal's triangle is divided up into row numbers. Okay, the top row is row 0. Then we have row 1 and row 2 and row 3 and row 4. You can tell the row number by looking at the first number that's not 1, except for this one's row 1, this is row 2, row 3, row 4, row 5. So that's an easy way for you to tell the row number. Well, why would the row numbers be important? You asked, or you thought it, or you're like, I really don't care. But the row numbers are important because they're going to help you be able to expand a binomial to a power without having to actually multiply everything out. So let me show you what happens. Since this is a binomial to the 6th power, we're going to use the 6th row. So I'm just going to slide this down so we're just focused on the 6th row. You can circle it if you want, or however you want to do that. But we're going to look at the 6th row.
Can you say it again?
I'm sorry?
Can you say it again?
Because a plus b is to the 6th power, we're going to deal with the 6th row to expand it.
Oh, okay.
So we're going to look at 1, 6.
A plus b to the 6th power is an example.
Yes, and we're going to be using this Pascal's triangle with the exponent in order to expand them. I want to show you how this works out. Okay, I'm going to leave some spaces between these numbers, but we're going to use all of these numbers to expand the polynomial. Okay, I'm going to use 1 and 6 and 15, and 20. I'm spreading them way out for a reason. And 15, and 6, and 1. Now, the reason I'm spreading them out is because we're going to take these pieces of our binomial and we're going to put them in with these numbers. So we're going to start with, if I multiplied a plus b times a plus b times a plus b, you can easily see that there would be 6 a's, right? A to the 6th power, definitely an a to the 6th power. So we're going to start with a to the 6th. And then each one of these, as we go this way, is going to be 1 less a. So we have a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, and then no a right there. Does everybody see what happened so far? We went down, right? For the other part, the part on the right, we're going to start at the right with b to the 6th. Like with this one, we're going to do b to the 6th. And then go from right to left and go b to the 5th, b to the 4th, b to the 3rd, b to the 2nd, and b. And then there's none here. And then all we have to do is put a plus in between. Okay, and the reason we put a plus in between is because there was a plus to start. Okay, these little ones can be cleaned up, so I can actually just write out my answer as a to the 6th plus 6 a to the 5th b.
This is your answer?
That's my answer. Plus 15 a to the 4th b squared plus 20 a to the 3rd b to the 3rd plus 15 a squared b to the 4th plus 6 a b to the 5th plus b to the 6th. I mean, quite honestly, the only reason I wrote the ones in the beginning and the end was so you could see what was happening. You can just have the implied ones on the beginning and the end and not, not even have to redo that. That is, if there's no coefficients here. If there are coefficients or numbers in here, it's not quite that easy, but you had to see the process. So the starting process is actually pretty nice and easy. Way easier than if I had to do a plus b times a plus b times a plus b times a plus b times a plus b plus times a plus b. Boil all that, distribute, put everything together, but when it gets put together, this is what you would get if you did that whole process. But the answer is just this, we're done.
The answer is just without the ones.
Huh?
The answer is without the ones.
So
I took out the ones because one times anything is
So
itself.
it's literally just the same thing you did without the ones.
Yep.
so a, for example, the first coefficient go to the first one down, and then the second coefficient go to the last, the first and go down.
Correct. Yeah, so,
Oh, you put it in order.
yeah, it's just in order. All I did was take the one out here and the one out here and just rewrote it. That's all. Yep,
And then we exactly this.
absolutely. Yep. Take a minute to write that down. Now, when we do this, when the coefficients are not 1, it's going to take, the hardest part of it is going to be the simplifying part. So if you don't have a calculator on you, now this is not even going to be for crazy calculator stuff. This is just going to be for multiplying out a whole bunch of things. But if you don't have a calculator on you, please grab one. People at home, you should be able to handle this also. Anybody else need one?
What do you mean when the key comes to the R one? You know, if you have one on the back.
Absolutely. The next one that we're going to do, if you turn on the back, it says 2
Ah,
and 3 to the 5th. So we're not going to have just an A and a B, we're gonna have something that we have to take to those powers. Okay, so everybody got what you need? Okay, so let's look at the next one. So this is what we see next here. We're going to expand, the direction would say expand, so in other words, multiply it out. We're going to expand 2x plus 3 to the 5th power, so which row are we going to use? 5th row, so I'm just going to slide this down so we're only looking at the 5th row so we have enough room. All right, now this is going to take us a little minute, okay? Because we're going to have to simplify things as we go. If we're looking at this, and we're looking at the first thing, we're going to think of this as this 2x as a unit. And I'm going to just do a little color coding here. I'm going to make the 2x in red, and I'll make the 3 in green so you can see it. Okay. And we're going to go across here. So that would mean that it would be 1, which we don't even need to write that, times 2x to what power? 2x to what power? 5th power. We're going to go down, and I'm going to leave a little space, and it would be 5, not 10x, we're going to stay with the 2x. 2x to the 4th power, and then we're going to leave a little space, and we're going to use what number that comes next? 10 times 2x to the 3rd. And then the next one is another 10.
Is there a reason you wrote 2x to the 3rd in the parentheses?
Oops, because I made a mistake. It should be 2x to the 3 should be on the outside. That definitely changes it, and we've got to be careful with that. It's important. So this should be 2x to the 3rd with the 3 on the outside. Thank you, Ryan. All right, and then the next one is 5, and just the 2x. And then there'll be a 1. Just trying to color code. The people on the screen, people at home can see this happening. 5 times 2x. All right, to the 1st power, and we've got a reserve 1 down here at the end, right? And then we have to go the other way with the 1. Okay, 1 times what? 3 to what power? 3 to the 5th power. Okay, I'm just going to put a little plus. Well, no, I can do this one will be 3 to what power? 3 to the 4th. This would be 3 to the 3rd. 3 to the 2nd. And then just the 3. And then since we have pluses here, we can just throw in a plus.
So I have a question. If it would be like minus, like 2x minus 3, all of them would be minus.
If we put minus in between, then these green things would all have a minus in them. We'd still put pluses in between, to be honest. We'd still put pluses in between, but then when we took the negatives to a power, that would take care of our pluses and minuses.
So now we simplify all of this.
Now we got to simplify it. Now here, this one, x is to the 5th power, but I need to take 2 to the 5th power, so I'm going to use the calculator a bit. And we're going to do 2 to the 5th power. I need my calculator to be dragged over. Sorry about that. So use your calculator and find out how much 2 to the 5th power will be. Okay, 32 you said? Okay, so just so that I can show this to everybody that's happening, we do 2 to the 5th power is 32. Okay, so 32 is going to be right here. Now, x is going to be to what power? 4th power. So we're going to have x to the 4th power. It's 5 times 2 to the 4th times 3. So this is where it takes a little bit more
so it'll be
of our
16
thought.
times 5 times 3.
So we're going to do 5, look at the screen, times 2 to the 4th power times 3. Because we've got to get all these. We get the original coefficient, 2 to the 4th times 3, and we get 240. So our numbers are going to start getting to be large.
140.
So 240x to the 4th. Then we're going to have a plus, and we need to put in 10 times 2 to the 3rd times 3 squared. So we're seeing 720, yep. 720 x to the 3rd. Takes some time, but you can see that it's not difficult, it's just knowing what to do. So if later on you need to know what to do, you can look back at this, you can watch the video even, people online if you're hopefully not getting drowsy or whatever. So times 2 squared times 3 to the 3rd power. So 1080, 1080 x squared plus another one, 10 times 2 squared, 2 squared times 3 squared.
It's not.
Right. 3 to the 4. Wait a minute.
Yeah, because we did 3 to the.
I did that one, I did that one, I did that one. Oh, I'm sorry, I'm on the wrong one. I need to do 5, yeah, sorry. Here. There we go. We're on this one because I don't have them lined up right. So 5.
Oh, yeah.
5 times 2 to the 4th
Oh, it just becomes.
times.
Why does it become 2?
Oh, sorry, 5 times 2. 5 times 2 times 3 to the 4th.
Oh,
There you
yeah.
go. 5 times 2 times 3 to the 4th. So 8, 10 plus 3 to the 5th, but that has a number. So 3 to the 5th, 3 to the 5th power. And 243. That's the answer. That's it. This is the shortcut because the alternative would be taking 2x plus 3, we're not doing this, don't write it down, times 2x plus 3, boiling it, then multiplying that times 2x plus 3, and then multiplying that, all that distributing back and
Yeah,
forth.
would be.
No, thank you. Yes. I think there's probably a downloaded calculator that you can, but I don't. I'll see if we can find one and have for you.
Okay.
But yeah, and if you can wait, you should wait. But if you are desperate, go ahead, because we have one more to do. Because this is where the negative comes in. Okay. So on this one, we're going to expand. We're going to go to row 4. Okay, 1, 4, 6, 4, 1. We're going to expand this one. Watch out here though, because this one has x is my first one, and then negative 2y is the second one. So we've got to be real careful. So we're going to do 1 times x to the 4th plus 4 times x to the 3rd, and then 6 times, oh, not x, yeah, 6 times x to the 2nd, 4x, okay, and then we come back here to the 1, and we're going to back it up, negative 2y to the 4th power. Okay, we can put a plus in here, negative 2y to the 3rd. We can put a plus in here. Negative 2y squared plus negative 2y, just negative 2y, and then a plus here. Okay, so when you're carefully working your calculator out, you're gonna have to watch your negatives. Okay, so let's do this. We have x to the fourth. This one actually is pretty easy. 4 times negative 2. This is just negative 8. And I can make that into a minus. Just negative 8x. Negative 8x.
So wait, what is the point of what?
To the third.
X to the third. Yes. I'm sorry. What? This one will be plus. Oh, y. No, it doesn't. Thank you. X to the third y.
I got confused with the second part.
This part?
Yeah.
If we do 4 times negative 2, that gives us negative 8. We have an x to the third, and we have a y as part of it as well.
And then y? Okay.
So this one is 6 times negative 2 squared. Calculator sliding. Stop calculator. There we go. So this one right here will be 6 times negative 2 squared. So that really is just 4 times 6, which should be 24. Positive 24. What about my variables? X. X squared. How about y? Y. To the second. Yep. You have to make sure. Yep.
It's not negative 24 because negative 2y is squared, right?
Because negative 2 times negative 2 gives you positive 4. Okay. And then over here, 4 times parentheses negative 2 to the third power. So negative 32. 4 times negative 2 to the third power. Here, 6 times negative 2 squared. That's this one right here. So 6 times 4, 24. 4 times negative 2 to the third gives you negative 32. So negative 32.
Gotcha. And then x.
Yep, negative 32. X. Y to the third. Negative 2 to the fourth power. So be positive or negative? Positive. The fourth power. So then
Why is my calculator say it's negative
16? Because I bet you put in like this. Okay? Because that means there's a negative out front of the whole answer. When you put it in parentheses, it's taking negative 2. And this is in parentheses. So it's got to be positive 16 y to the fourth power. Okay, so that's how that all works out. That gives you your complete answer. Yes, it's a process, but it's not an oppressive process that's going to take you 15 hours. And it's way better than having to multiply that whole thing out. So there we go. In the notes, I've actually got the different pieces that you would have to multiply all out. And even if you didn't want to use exponents, like for this one, you could do 10 times 2 times 2 times 3 times 3 times 3. So even a basic 4-function calculator can do that for you.
What?
You just have to be careful,
Yeah.
okay, what you're putting into it and telling it to do. So like for this one, I could do 10 times 2 times 2 times 2 times 3 times 3 if I wanted to do that out like that. Yeah. And so that's that. And basketball players, hope you're having a great time and do your homework. Be safe coming back.